Rewrite the Cartesian equation x squared plus y squared equals 6y as a polar equation. Well, remember when we do that, we want to change all the x's and y's to r's and thetas. Okay, so remember, x is equal to r cosine theta, y is equal to r sine theta. So what we can do is replace our x's and y's at this point. So let's try. Replacing x squared would be r cosine theta squared. Replacing y squared with r sine theta squared equals 6 times y r sine theta. Okay, so if we use our exponent rules here, we get r squared cosine squared theta plus r squared sine squared theta equals 6r sine theta. We can factor in r squared out. And remember, cosine squared plus sine squared is 1. So 1 times r squared is r squared. So what we're trying to do is solve for r. That's the whole purpose. Whenever you have a polar equation, it's r equals something, okay, with theta in it. And now we have an r on both sides. If this term did not have an r, we could just take the square root of both sides and be finished. However, it does have an r, so we need to move this term over and factor out an r. Now we set them both equal to 0, and we want to solve it from there. Well, if r is 0, remember r is a radius, so this is just the point 0, 0. It really means nothing to us in the context of this problem, so this one tells us nothing. So add 6 sine theta to both sides, and now we have solved for r. So what we want to do is see if these two equations look the same when you graph them. The problem is, whenever you graph a Cartesian equation, you need to have it solved for y, because that's how you put it into your calculator. So we have y's on both sides. What I need for you to recognize is that this y is squared. Okay? That means we have some sort of quadratic going on. Remember, quadratic equations are normally of the form ax squared plus bx plus c equals 0. And your a, your b, and your c are just your coefficients and your constant, where your variable is x. Well, in this case, our variable is going to be y. So let's put everything on the same side and just see how it looks compared to the general form of a quadratic equation. So we will subtract 6y from both sides. Well, remember I said that since the y is squared, that's taking the place of the x up here. So now our variable is actually y. I need to write it as y squared minus 6y. This term does not have a y in it, just like this term does not have an x in it. That means x squared is actually our constant. I know this looks a little strange, but stay with me. This is a quadratic equation where a is 1, b is -6, and c is x squared. That's your constant right there. We can actually use the quadratic formula to solve for y. So y is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. That would be 6 plus or minus the square root of 36 Negative 4 times 1 times x squared is negative 4x squared all over 2. We have now solved for y. By the way, I put a box around that, but that's not really the answer. The problem told us to write this as a polar equation. So this is actually our answer right here. What I want to do is graph both of those and see if they look the same. So let's use our calculators and review. So right now, oh, I already have it in here. That's nice. I don't have to retype it. We have 6 plus the square root of 36 minus 4x squared all divided by 2. That's the plus one. And then we also have the minus one. So if we graph it, we get this nice little circle. Okay, that's actually this one right here on the rectangular coordinate plane. Okay, so what if we put in our sine theta as our polar equation? So change to mode, change to polar, go to y equals 6 sine theta graph. We get the same graph as whenever we graphed the rectangular one. Both of these represent the same picture.